Hello and welcome to today's video. We're going to talk about power sets. So this is the set of all possible subsets. So it's obviously really closely related to the last video where we talked about subsets. So make sure you have a good grasp on those. And it's notated by P of A. And I really want you to do a quick example here because it's fairly intuitive. If you understand subsets, you should be able to think about the set containing all subsets. So let's say A equals just 1. It's an element. It's the set containing 1. I want you to give me P of A, so the power set of A. Maybe pause it and try to think about this for a second, or I'm just going to go right through it. So the power set of A, I instantly think, okay, if it's the set of all possible subsets, I need to include subsets, so you have to put that in set notation because it's the set containing subsets, so those are sets. And obviously I see, well, it's obviously the set containing 1. Now the big question is, am I done? This is something a lot of students struggle with. They think that that's it. But remember, the empty set is the subset of any and all sets. So the empty set is a subset of A, so that has to be included in the power set. So I'll write the empty set like that right there. So those are the two. That is the power set of the set containing 1. So that's the set of all possible subsets. We get the empty set and the set containing 1. So to determine the power set by hand, so not everything's going to be so easy with just one element, so we need a method to determine the power set by hand. So what you do is you begin with the empty set, because like we said, we know the empty set is part of everything, and we move down one element at a time, and we either add the element to the set or we keep the element out of your set. And then after doing this for all the elements, your bottom row will be your power set. This can be confusing right now, but we're going to go through an example and I promise it'll make more sense then. It's a pretty intuitive way to do it because obviously you're just taking each element and you're saying I can put this one in or I can take it out. And that'll make it clear for what we mean. And so another important part of power sets is understanding the cardinality, and it's a really good way to check your work. So if the cardinality of set A is n, then the cardinality of the power set is 2 to the power of n. So you do 2 raised to the power of the number of elements in your set. And why does this make sense? Well, each element, so if I have n elements, those n elements can either be in the set or not. So you have 2 options for each of the n elements. So what I'm doing is 2 times 2 times 2 times 2 for however many n elements I have. So it really makes a lot of sense why the number of elements in the power set is going to be 2 to the n, because I can either have the element or not have the element. If you notice, that's exactly what we did here with our first example. So the cardinality of A, in this example, it equaled 1, right? And the cardinality of the power set of A, well, this rule says it should be 2 to the n. Well, 2 to the first equals 2. And that's what we had here, because we had the cardinality of the 1 of the set containing 1 is just 1, obviously, and the number of elements in the power set was 2. But well, what about this rule that says you can either keep the element or you don't keep the element? Well, that's what we did, right? So we started with the empty set, and then we said we're going to keep 1, and that's how we got the set containing 1. And then we also said, well, we're not going to keep 1, and that's how we got the empty set. So that's kind of the intuition. Now let's get into a real example of how you use this tree method. So we have A equals the set containing -1 and 3, and we want to know the power set. So let's start off with just doing the tree method. So it says start off with the empty set, and then for each element you either keep it or you take it out. So you either add it in or you take it out, I should say. So let's start with this one row. We're going to do -1. So add or don't add. So if I add -1, I now have the set containing -1, right? Because I don't need to write the empty set, it's basically implied. And if I don't add it, I have the empty set. Okay, so now I have the next row, which is going to be the 3. And then now I have 4 branches this time because I need to add or not add for each set that I'm dealing with. So I can add 3, so add. I'm just going to say DA for don't add. I can add or I can not add it. So okay, so if I add the 3 to this set, I have this set containing -1 and 3. If I don't add the 3 for this set, I have the set containing -1. If I add the 3 to the empty set, I just get the set containing 3. And if I don't add the 3, I just am left with the empty set again. And now we've done it for each element, right? We did it for the -1, we did it for the 3, so that's the elements are done. That means this right here is our power set. So this is P of A right here. This is the set containing all possible subsets, and I'll write it out clearer here. So P of A equals, well, it's the set then inside of it is all the possible subsets. I'm actually going to start with the smallest and go to the biggest, so we'll start with just the empty set, and then we'll go to the -1, then we'll go to the 3, and then lastly we have the set containing both -1 and 3. And that is the power set right there. That's the set containing all possible subsets, because each time we had the option to either keep the element or we could take out the element. So we have every scenario. We have if you include the -1, we have if you include the 3, we have if you include both, and we have if you exclude both. So if you include none of them, that's what you get, the empty set. And I hope you guys notice that you don't have to write the empty set, even though it's technically a part of all these sets. You only write it when it's by itself. So let's talk about cardinality. So this is a way to check our work. That's the rule. So cardinality of A in this case was 2, right? Because there's 2 elements, 1, 2, the -1 and the 3. That means the cardinality of the power set of A should have been 2 to the power of n, which was 2 in this case, which equals 4. And was that the cardinality of our set? Well, we have 1 element, we have 2 elements, 3 elements, and 4 elements. So it was. So that's a good way to check our work, and right now it's checking. It looks like we did a good job. So that's the power set of A there. So some possible areas of confusion with power sets. This is a complex topic, and I really hope you guys can kind of understand this, but understand some of these tricks. So first, the power set of the empty set is just the empty set. This is something some people can find difficult because they think, well, what's the power set of something with nothing inside of it? Well, remember here, let's let A equal the empty set, and it says, well, now I want to know the power set of A if it's the set containing an empty set. Well, remember it's 2 to the n, well, now we need to think, well, what is the cardinality of A? Cardinality of the empty set, remember, is 0. There's no elements inside of it because the empty set is just this right here. So the cardinality of that is 0. There's nothing in there. So that's why P of A, in terms of elements, is going to be 2 to the 0, which equals 1. So that means that there has to be one element in the power set, but if the power set is the set containing all possible subsets, that needs to be the set. So let me write P of A here. So P of A has to be, well, we have a set and then all possible subsets. Well, the only subset that I can have of the empty set is the empty set. So that's what I get, and that's where that one element is. So that's one element, and that's why the power set has one element. And so hopefully that makes sense. Hopefully you kind of understand the intuition behind that, because that can be a tough topic. So now the second one, we're looking for the power set of the set containing the empty set. So think about this for a second. The power set of the set containing the empty set, and the answer is that we have the empty set and the set containing the empty set. So you really have to think about this. So if we have A equals, I'm going to write this as the set containing the empty set. This is a common just area of confusion in general when teachers do the set containing the empty set, because you really have to think about this in general. So we kind of have an element to this, right? Because now this whole thing is an element. We have something inside of the set, and that is the set containing the empty set. So the way I like to think about it is, okay, well, the cardinality of A now is 1 because I have an element. The set containing the empty set is an element, even though the empty set is not an element. If I have a set containing the empty set, I do have an element. So I know that the cardinality of the power set of A has to be 2 to the first, which is 2. So I know I have to have 2 elements in my power set. That's how I always start these things off, because it kind of gives me somewhere to go off of. So now if I think about my power set, I need the set of all possible subsets. Well, I know the first one is obviously going to be the set containing the empty set. And then I see, okay, well, I know my cardinality needs to be 2, so there's got to be something else in there. And the way I think about it is, remember, this empty set is a subset of everything, and I don't have the empty set yet. I haven't put that in my power set. I've put the set containing the empty set, but I also need room just to have the empty set. That always needs to be a part of my power set. So this next one is A a subset of the power set of A? And the answer, like I wrote here, is no, it's not. And that's one we really need to think about here. So let's look at our original example. We had A was the set containing 1. And power set of A was the set containing the subset of A, a subset of 1, and also the empty set, right? So in this case, remember, a subset B is a subset of A if all the elements in B are in A. So all the elements in A are 1, right? That's the element in A. Is that an element of power set of A? So is 1 an element of the power set of A? If it is, then it's a subset, right? But if it's not a subset. This is where you have to be careful. 1 is not an element of the power set of A because this answer is no. So no. And that's where you have to really be careful, because you might be looking at this, say, are you crazy? It is. But no, the set containing 1 is an element of the power set of A. But 1 is not. So yes, this is true. But 1 itself, and that's that number, the element inside of the A is not in the power set of A. The set containing the element is. So that's the kind of the difference. That's what makes this not a subset. This is kind of one of the more confusing things that we're going to have to talk about. But that is true. That is not true. A is not necessarily, it can be, but it's not necessarily a subset of the power set of A. There's certainly cases where it is true, but it's not always true. So next one. So is A an element of the power set of A? And this one's always going to be true. So yes, and that's kind of what we talked about here. A is the set containing 1, and if the power set is the set containing all possible subsets, and remember, a subset can be equal to the original set, that's fine. Well, then obviously that's going to be an element of the power set. And so here we see that A, like we said, is the set containing 1. Then like we said here, that set containing 1 is an element of the power set. That'll hold true for all examples. That's always true. That's kind of the key difference there, is that it's always an element. It's not necessarily always a subset. And so this kind of answers our question. This is kind of, the number 5 kind of explains number 3 a little bit more. So is 1 an element of this set? And no, it's not. That's because the set containing 1 is an element of the set with 1, 3. But 1, let me say 1 is an element. I didn't mean to say equals. So 1 is an element. The set containing 1 is an element of that. But 1 is not an element of that set right there, because one of my elements isn't just the number 1, right? I have one of my elements is the set containing 1, and my other element is the number 3. But the set containing 1, really this comes down to this right here. The set containing 1 is not equivalent to the number 1. They're two different things. And that's what it comes down to. That's kind of why number 3 is no, and number 5 is also no. It's the same reasoning there. So those are kind of the tricks. I know that can be really confusing here, but hopefully you kind of understand what power sets are, and you get these notes down. And the important rule for me, at least, is the cardinality one. That one really helps me out to think, okay, well, it's just 2 to the n, and then I can kind of work my way to the correct solution from there. And you can use the tree method as well. Thanks for watching, and let me know if you have any questions. Have a good one.